Assalamualaikum and hello everyone. So today I would like to show you how to do the simulation for lab 3 technical physics for coefficient of static friction. Go to the website and then find force and motion basic. Okay, there you go. Click and then wait for a while and then click again. Then wait and then choose friction. Okay, first choose the box with mass 50 kg and then set the apply force 50 Newton and then you can see the result. Okay, this is for box in motions. Apply force is 150 Newton and the mass of the box still 50 kg and then you can see the maximum value of the static frictions go to 94 Newton and sum of force 56 Newton. And then you can get the value. That's all. Choose the box with mass 100 kg when the box in motion and then apply the force to 500 Newton and then when the box is still moving, remove the apply force to 0 Newton. Immediately reduce surface reaction to none. Observe the effect on the box movement, you can see there. Then increase the surface friction to lots. Then you can see the movement.
Good afternoon. Today I will show the lab 3 of part B, which is coefficient of static friction. This is actually friction. So we will click the following link. I already clicked the link, which is this link. And then we go to inclined plane with friction, 2 masses. Pulley. And after that, you will see the procedure given. We need to set an angle at 0 degree, mass of M2 10 kilogram, and coefficient of friction is 0.25. So start with 0 degree and then the mass of 10 degree and coefficient of friction is 0.25. Okay, the procedure given, we need to slowly reduce the mass of M1 until the M2 is barely moving towards M1, this one. So we will try with the lower mass to see if the mass of M2 is moving, which is 3 degree, it's still moving. Proceed to 2.9, still moving. 2.6, 2.5. Okay, 2.5, the M2 is not moving towards M1. So the mass of M1, which is the M2 is barely moving towards the M1, is 2.6. We'll see. Okay, the M2 is moving towards M1. So in the table given B1, which is weight M2 is 10 kilogram, convert to Newton, and the load of hanger M1 is 2.6, which is this mass of M2, and we convert to Newton, and we proceed to 8 kilogram, 6, 4, and 2 to find the load of hanger M1 at the simulation here. Okay, after that, continue with the table of B2, which is 30 degree of the surface. We set the surface to 30 degree. Okay. And then we repeat the procedure of the table B1, which is the mass of M2 10 kilogram, coefficient is 0.25, and we need to know the load of hanger, which is M1. So we will try with 2.6. You see 2.6, the M2 not moving towards M1, but M1 get up to the M2. So we need to use the bigger mass. 8 kilogram. We'll try 7.8. 6.8 is not moving. 6.9. 7.2 not moving. Okay, 7.2 is moving. The M2 moving barely towards the M1. So the load of hanger in the table, we will write the 7.2 kilogram. After that, we will move to table B2, which is dry concrete on rubber. Dry concrete on rubber, the coefficient of friction is 1.0 in the simulation. So we will set the angle first with 0 degree, then mass of M2 is still 10 kilogram. The coefficient we will change to 1 as the procedure said. So in table B3, we will see 10 kilogram. It's not the M1. If we give the maximum mass of M1 in the simulation, it is still not moving because it's in the dry rubber, and the coefficient of friction is 1. So in the table, we will not get the value of the load of hanger. And we will try to 8 kilogram. Mass of M2 8 kilogram. Okay, 8 kilogram. Then we will try the M2 moving barely. This is not barely. Moving to M1. We will try with lower mass. 7.7 is not moving. 1.8. It's at 8.1. 8.1, the M2 is moving to M1, moving barely. So in the table, we will write 8.1 kilogram, and then we change to Newton. Then we proceed to 6 kilogram, 4 kilogram, and 2 kilogram, and we got the result here. After that, we will move to table B4, which is the angle is 30 degree. 30 degree. Okay. So we will try with 10 kilogram mass of M2. Still same weight of M2 weight. And we will try with load of hanger M1 with 10 kilogram. So it's not moving because it is 30 degree of angle. So the 10 kilogram here, the load of hanger, we will not get the value, and also 8, we will not get the value. We will see here, still not moving, even though the M1 is 10 kilogram. Then we will try with 6 kilogram. 6 kilogram, okay. Okay, it's moving. The M2 moving to M1. We will try reduce the mass of M1. 6.3 is not moving. 0.4, 0.5, 6, 9. You see at the table, it said 8.3. 8.2 is not moving. We will try 8.3, and the M2 is moving towards the M1. So this is the barely moving of M2 towards M1. So the load of hanger will get 8.3 kilogram, and we will continue with 4 kilogram of M2 and 2 kilogram of M2, and we will get the result here. That's all from me. Thank you.